In section 3.2, we're looking at what happens when parallel lines are hit by a transversal. We looked at special angle pairs yesterday off of a transversal. We looked at corresponding angles, alternate interior angles, alternate exterior, and consecutive interior angles. But today, what happens, little discovery here, what happens if two parallel lines are cut by a transversal? You notice these two lines are parallel because they're marked as such with those arrows. We have a transversal here because it hits two other lines. What is special about these angle pairs that are formed? You notice I numbered the angles 1 to 8 again. Well, I'm going to start out and actually label something we already know. Now, I'm going to put a smile face in two angles I know are congruent. And I hope that you would agree with me that angles 1 and 4 have to be congruent, so they both get a smile face. Why do I know they're congruent? Because these are what types of angles, and you should be thinking those are vertical angles. I know they have to be congruent. I'm going to pick this flower, and I know that angles 2 and 3 are also congruent. Why? Because they are another pair of vertical angles. But what I'm really curious about is there something special that happens because these lines are parallel, that are cut by the transversal. Is there a relationship between angles 1, 2, 3, and 4 and 5, 6, 7, and 8? And I hope that you're thinking it looks like 1 would be congruent to or the same as 5, and 2 would be congruent to 6, 3 congruent to 7, 4 congruent to 8. And I can test that out by taking this whole picture, and I'm going to copy and paste it. And really, I just duplicated this entire thing here. Now, I want to see if 1, 2, 3, and 4, which I copied here, are the same or congruent to 5, 6, 7, and 8. So I'm going to drag this over and take a look. They definitely match up, exactly coinciding. 1 is coinciding with 5. 2 is coinciding with 6. You can see the overlap of those numbers. 3 with 7, 4 with 8. So it is kind of neat. We have all these angles duplicated here. Now, would this happen all the time or only if the lines are parallel? Well, if the lines are not parallel, then one line would be off, right? This line would be if it would not be parallel, it would be a different angle than the other one, so the angles would not be congruent anymore. But as it turns out, when the lines are parallel, those angles above are the same as the angles below. So now, couldn't I put a smile face as a congruent symbol in angles below? 1 and 4 are congruent to 5 and 8. All 4 of these angles are the same measure because these lines cut by that transversal are parallel. And when I grab my flower symbol, I know 2 and 3 would be congruent to 6 and 7. Now think about those terms from yesterday. What kind of angles are 1 and 5? Those are the ones that overlapped or matched up. Remember that those are corresponding angles because they make that same shape as you slide down. 2 and 6 matched up. Again, corresponding angles. 4 and 8, 3 and 7, again, corresponding angles. Now we have a lot of theorems to write down because of this. Really, the basic thing that we're noticing is corresponding angles are congruent. This is written as a postulate. Corresponding angles postulate. Remember, postulates are things that kind of make sense to us. More of a common sense thing, can't be proven, but this is where we're starting because we saw corresponding angles were congruent by doing copy and paste. So, all of these begin with if two parallel lines are cut by a transversal. Then we know corresponding angles are congruent. Also, we know that alternate interior angles are congruent. Also, we know that alternate exterior angles are congruent, given by alternate exterior and alternate interior angles theorems. Remember, theorems can be proven. We're going to prove one of these in a little bit. And I'm going to go back real quick and check that out. Are alternate interior angles congruent? Are alternate exterior angles congruent? Remember, alternate interiors, they have to be in between these two lines on opposite sides. Look at that, 3 and 6, alternate interiors, both congruent, marked with a flower. 4 and 5, alternate interiors, marked congruent with those smile faces. What about alternate exteriors? Remember, they're totally opposite on the outside, like 1 and 8, marked congruent, both get the smile face. 2 and 7, yes, alternate exteriors, congruent, marked with a flower. The only thing on here that's a little bit different is that consecutive interior angles, this theorem is not saying consecutive interiors are congruent. Consecutive interior angles are supplementary. And remember that supplementary means they add to 180 degrees. if you have two parallel lines cut by a transversal, there are only two options for what can happen. If you pick two angles. If you pick two angles, they're either congruent or supplementary. Back in this picture, why are consecutive interiors supplementary? Because consecutive interiors, remember, on the same side of the transversal in the inside because they're interiors, so 3 and 5. They're not congruent. One's the flower, one's a smile face, right? One is acute and one is obtuse. The other pair of consecutive interiors is 4 and 6. They're on the right side of the transversal. You notice 4 is obtuse, 6 is acute, one smile face, one flower. Well, what do you know about every pair of a smile face and smile face and flower angle? Is they're next to each other on a line commonly. And you know that angles next to each other on a line are called a linear pair. They are supplementary. They do add to 180 because they make up a line together. So anytime you have a smile face and a star, they're supplementary. They add to 180. You only have two options. When parallel lines are cut by a transversal and you pick two angles, you have two options for any two angles. There's my angle symbol in plural. Either they're congruent, either they're exactly the same, or they are supplementary, meaning they add to 180. One way to tell, are they a special angle pair? Because then they're congruent. Is there one obtuse and one acute angle? Because then they're supplementary, meaning they add to 180. So we could do something. I could pick any two numbers, 1 through 8. I could pick 1 and 6, and I say congruent or supplementary. 1 and 6. Well, one's a smile face, one's a flower. This is obtuse, this is acute. I know they're supplementary, they add to 180. I pick two numbers, 2 and 7. 2 and 7. Look at that. They're both flowers. They're also alternate exterior angles, therefore they are congruent. Right? They're both acute, they're both marked with the flowers, they're congruent. So you only have two options when parallel lines are cut by a transversal. They're all listed here. That if that condition is met, that the lines cut by the transversal are parallel, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. The consecutive interior angles, however, are supplementary, meaning they add to 180. I'd like you to be familiar with just using these titles. Remember, corresponding angles is the only postulate, the rest are theorems. Let's use some of these here. Find the missing numbered angle measures. Give a reason for each. So I have to find the angle measure of all of these that are marked, angles 1, 2, 3, and 4. Remember, if I'm going to give the measure, I have to do that m in front. So what does the measure of angle 1 equal? This is the only angle I know. It's 50 degrees. I notice these two lines are marked parallel because of the arrows. They're cut by this transversal. I'm looking for special angle pairs. I'm looking for things I knew even before today, which is something that happens with angle 1. Because what type of angles are angle 1 and this 50 degrees? You should actually be thinking, hey, those are vertical angles, right? Those are angles opposite from each other when two lines intersect. What do we know about vertical angles? They are congruent. Therefore, angle 1 is 50 degrees. And my reason here, how do I know that vertical angles are congruent? Back in the previous chapter, we had vertical angles congruence theorem. And I'm just going to write vertical angles. That's good enough for me. But it is vertical angles congruence theorem. What about the measure of angle 2 in this picture? Here's angle 2. Take a look at angle 2 compared back to the 50 degrees I already knew. These are a special angle pair that we've talked about just a little bit ago. Angle 2 above the transversal to the right of one of the lines. Angle 50 above the transversal to the right of this line. They make that same shape, and those are called corresponding angles. And what do we know about corresponding angles when parallel lines hit by transversal? They are congruent. Angle 2 is also 50 degrees. And the reason why we said they are corresponding angles, and remember that corresponding angles was our starting one. This is a postulate. This is the accepted without proof one. I'm going to go back and make sure corresponding angles postulate. That's how I know that angle 2 is 50 degrees. So what about the measure of angle 3? Angle 3, back to my 50 degrees. I take a look at these two, I notice they're both acute. That must mean they're both congruent. And actually, they are a special angle pair. Maybe that's the first thing you notice. They're both interior angles because they're between the parallel lines. They're on opposite sides. These are alternate interior angles. And I know that alternate interior angles are congruent, therefore angle 3 is also 50 degrees. So they're both acute. And it's alternate interior angles theorem, which I can abbreviate. And finally, what is the measure of angle 4? Take a look at angle 4 and compare back to that 50-degree angle that I was given. Now you notice angle 50 degrees was acute and angle 4 is obtuse. These are both interiors. They are both above the transversal, meaning they're on the same side of the transversal. Remember that these are actually called consecutive interior angles, same side transversal, because they're both above in this case, interiors. And since one's acute and one's obtuse, they're not congruent, they're supplementary. Remember that is our other option. Consecutive interior angles are supplementary, they add to 180. If these two add to 180, if this is 50, this would have to be 130 degrees to add to 180. And my reason why is because these are, again, consecutive interior angles. And these are the ones that add to 180. They're supplementary. Consecutive interior angles there. So you'll have a few examples like this today where you have to give a reason for each angle, always referring back to the original angle that you were given. Looking at special angle pairs hit by parallel lines. Alright, let's find all the angle measures in the diagram. The cool thing about parallel lines being hit by a transversal, and you notice these are parallel because they're marked that way, you only need to know one angle measure, and I can find every angle measure in this entire diagram because these lines were parallel that were hit by that transversal. Now, whether or not I knew those lines were parallel, I could find all 4 of these angles because I know that vertical angles are congruent. This would have to be 70 degrees. And I know that these two angles have to add with 70 to give me 180 because they're all linear pairs. And so that would have to be, what, 110 degrees to add with 70 to give me 180? No matter what, I can find those. But because of the fact that these lines are parallel that are hit by the transversal, I know my corresponding angles are congruent. So I know that the corresponding angle here would also be 70. And the corresponding angle here would also be 70. These are vertical. I know these corresponding angles are 110. And we see that they kind of match up these 4 with these 4. So it's kind of neat when parallel lines cut by a transversal. If you know one angle, you actually know all 8 in the diagram. Alright, now some algebra to deal with this, go along with this. You notice in both of these pictures I have 2 parallel lines shown by the arrows cut by a transversal. You have 2 angles marked and given expressions for. Now there's only 2 options. You ask yourself, are those 2 angles congruent? Because they might be congruent. They might be alternate interiors, alternate exteriors, or corresponding angles. Or are those 2 angles supplementary? Meaning what? That they add to 180? Maybe they're consecutive interiors, or maybe they're just some other random 2 angles that don't have a special name but are supplementary. So those are the only options. Now if they're congruent, what are you going to do? You're going to take them and set them equal. If the angles are supplementary, you're going to add them up to 180. Those are your only 2 options if you have 2 angles marked in a situation where parallel lines are cut by transversal. So in this case, these are the 2 angles I'm dealing with. This is 8x minus 8. This is 3x plus 42. Before I worry about the algebra, are these angles congruent? Are these angles supplementary? Only 2 options. And you look at these and you say, wait, these are corresponding angles. Also, I notice they're both obtuse. Now, whether I say corresponding angles are congruent or whether I said they're both obtuse, so they'd have to be the same, I know these angles are congruent. Corresponding angles are congruent when parallel lines are hit by transversal. So I'm going to set these things equal. They're congruent angles. They have to be the same measure. So 8x minus 8 would have to equal 3x plus 42. There's the geometry part of it. Let's do the algebra and solve for x. I would subtract 3x here and get rid of that. 8x minus 3x is 5x. Minus that 8 equals 42. I'm going to add 8 to both sides. 42 plus 8 is 50. I'm going to divide by 5 on both sides, and x equals 10. Okay. And what about in this next problem? I have an angle of 135. I have an angle of x minus 30. Parallel lines cut by a transversal. Are these angles congruent or are they supplementary? My only two options. Well, wait a second. I don't really think these are a special angle pair. I noticed that this is obtuse, greater than 90. This is acute, less than 90. These are not congruent. They're definitely supplementary then. So I know that these two angles would add up to 180. So I take the x minus 30. I take the 135, right? The two angles, I add them together, and I know they're supplementary, so they would add up to or equal 180 together. Combine like terms, negative 30, positive 135. So this would be x plus 105, and that equals 180. I'll subtract 105 from both sides, and x equals 75. So again, if two parallel lines cut by transversal, your options are they might be congruent, so set them equal. They might be supplementary, so add them up to 180. Alright, here's the fun part. Let's prove one of our theorems today. Let's prove the alternate interior angles theorem. And we're only going to use the corresponding angles postulate, because remember, postulates are the ones that we kind of assume without proof. That makes sense. So I can only use corresponding angles, and I want to prove that these alternate interior angles are congruent. Notice these are alternate interiors, right? Opposite inside angles. So I'm given P is, the symbol means parallel, of course, to Q. I'm going to mark P parallel to Q. I'm trying to prove that these alternate interior angles are congruent. Now I have to do a little bit of work, and my question to you is there an angle that we could label in this diagram? Is there somewhere I can put a number 3 for angle 3? That would be a corresponding angle with one of those. A corresponding angle with either 1 or 2. But is also a special pair with the other angle. Because if I can only use corresponding angles postulate, I need to label an angle in here that is a corresponding angle with either 1 or 2. But also is a special pair with the other. Because I'm trying to prove these are congruent, but I can only use corresponding angles. And I hope that there's two specific angles that you could label as angle 3. You could label angle 3 here, because then angles 2 and 3 are corresponding angles, right? Same shape off of the parallel lines. But also 1 and 3 are a special pair. Those are vertical angles, and you know those are congruent. The other place you could put an angle 3 would be right here. Reason why? Because you know 1 and 3 are corresponding in that case. And then 2 and 3 would be a vertical angle pair. Okay, so 2 spots that I can put that angle 3. It's kind of up to you where you want to label it. Maybe I'll put the 3 here. And set up a proof with statements and reasons. And actually that angle 3 is all that I will need to be able to do this proof, and prove eventually that angles 1 and 2 are congruent. So I was given that P was parallel to Q. That's where I'll start. Now remember, the only thing that I can use is corresponding angles postulate, which says if two parallel lines are cut by transversal, corresponding angles are congruent. Let me go back and check that. Right? If two parallel lines are cut by transversal, then corresponding angle pairs are congruent. That's corresponding angles postulate. So, since I can use that, I know P and Q are parallel lines. Where are my corresponding angles so that I can say corresponding angles are congruent? The corresponding angles in this case are 2 and 3. Same shape off of those parallel lines. Since P and Q are parallel, I know angle 2 is congruent to angle 3. Why? Because again, they are corresponding angles, and this is corresponding angles postulate. I'll abbreviate postulate. But we also had another special angle pair. Now 2 and 3 were congruent because they're corresponding angles, but what other pair of angles is congruent in this picture because they're a special angle pair? How about 1 and 3? I know angles 1 and 3 are congruent because they are what types of angles? You should be saying those are vertical angles, 2 and 3. Technically it's vertical angles congruence postulate, but I can just be fine with vertical angles. Remember how we're trying to prove that 1 and 2 are congruent? You know what? They are congruent already. I know angles 1 and 2 have to be congruent. Why? Because angle 1 was congruent to 3 and angle 2 was congruent to 3. Angles 1 and 2 were both congruent to angle 3, therefore they have to be congruent to each other. There are two different reasons you could put for this. When two things are congruent or equal to the same thing, you can say they're congruent or equal to each other by transitive property. Technically, transitive property of congruency, because we had congruent things. Or, whenever things are congruent or equal, like instead of 3 here, I'm just putting what 3 is congruent to, which is angle 2. You can say that's substitution. So either or will work. So looking at parallel lines, cutting and transversal, and congruent angle pairs today. Alright, last picture. What kind of angles are shown? You notice we don't have like the full picture. We don't have parallel lines marked. We don't have necessarily a whole picture shown with two lines being cut by transversal, but that is the case here. If you imagine these lines being extended, you will get a picture of what kind of angles we have. So what kind of angles are these? Well, if you imagine this line being extended here, and this line being extended here, we'll extend here, and here, you should get a better idea of what angles are in this picture. But we don't need this whole thing. We notice, oh look, there's my two lines that are cut by this transversal. These angles are on the same side of the transversal. They're interior. Now, same side interiors are called consecutive interior angles. If those lines are parallel, then they'd have to be supplementary, right? They'd have to add to 180. What about here? What kind of angles are shown in the picture? Now, we talked about this Z shape being a familiar one and giving you a special angle pair. If you imagine these lines extending, it should make it a little bit more clear what kind of angles we have. Oh look, they're between these two lines, they're interiors, they're on opposite sides, these are alternate interior angles. And remember that alternate interior angles always give you that Z shape. So be able to identify these special pairs of angles just from a abbreviated or not full picture as well.